There we are. Hello. So just before we kick off, a couple of notes. At the bottom of all the slides are my Twitter handle if you want to get in touch during or after the talk. I won't be responding during the talk though. The Twitter handle for Vonage, which is a company I work for and I'll tell you about in a moment, and a link to this entire slide deck. So if you would rather have them on your own machine, have them open in another screen, or refer back to them later, that is a perfect place to check them out. And just so you know, I have a screen down here and I have the little comments thread going down here. So I promise I'm not distracted, but I'll check in on the chat occasionally. So if you have questions as we go, by all means, please do drop them in. So as mentioned, I work for a company called Vonage. We are a cloud communications platform that provides APIs, which we'll talk about today, not just in the context of Vonage, but Vonage provide APIs that allow you to integrate voice, video, and messaging and two-factor authentication into your projects. I'm also the lead organizer of a conference series called You Got This. And in fact, some of the speakers over the next few days have been speakers at the You Got This events, which is awesome to see, including Suze, who's over here. He's over here in the chat. You Got This is a community conference series all about core skills, sometimes called soft skills, needed for a happy, healthy work life. This whole conference series was created because we don't talk enough about the thoughts and feelings that people have in tech, especially the kind of topics that just aren't taught. I'm really happy to see that a lot of these themes are being covered over the next couple of days. But if you want even more, we have a free talk library, all the talks from previous events. At this point, it's over 45 talks available for free with transcripts. So you can go ahead and, strengthen your core skills by going to check that out. You can find a link in my Twitter bio or at yougotthis.io. Let's talk a little bit about... Yes, the dungarees. Honestly, my wallet has hurt a lot in the last 12 months. Basically, anything I would have spent on travel or like eating lunch when I'm at the office has gone straight into dungarees. So just to kind of explain a little bit about how this session is going to work, it's mostly going to be a talk with a few interactive segments. But if you have any questions, pop them in the chat and I'll try my best to answer them as we go or afterwards. So we're going to start by talking just a bit about APIs and the concepts surrounding them. Then we'll use a couple of APIs ourselves. And at the end, we'll talk about just in passing some slightly more complex concepts that you might want to have in the back of your mind as you're starting to use APIs. Someone's asking where the slides are. There is a link at the bottom, lws.io/slides/APIs, and that is this set of slides. And as well as that, this will be a session that is recorded. So let's talk about APIs. What is an API? An API is a set of allowed instructions made available to developers that allow them to interact with a website or an application or a system. And they are often presented along with documentation, which are sometimes called docs or API references that describe all of the allowed instructions, all of the options and variations that might exist, and what you can expect as a result. You can very much think of this like a restaurant menu. You have all of the dishes, you have the options. Are you going to go for a salad? Are you going to go for fries? And what you can expect back as a result, and that being the description or perhaps the photo of a dish. One of the benefits of APIs is that they are, for the most part, language agnostic. As long as you can make a web request from your application, you can integrate with most APIs. Let's do a quick whirlwind tour of some APIs that I found to kind of demonstrate the breadth of them. This is one, the Audio DB, which provides loads of information about music, including metadata and cover images. So you can use this API if you're wanting to display or access information about music tracks. We have the Google Maps API, and there's actually quite a few Google Maps APIs. This one I'm showing here is the Directions API. This allows you to, plot point A and point B, provide a method, whether or not that is driving, walking, cycling, and it will provide a set of directions. So you don't have to work out the directions yourself. If you're building an application, you can go ahead and use this API. Another API you may have heard of before is Stripe, which is one of the go-to APIs for when developers are accepting payments on the web. There's a lot of difficult parts about taking payments and a lot of bits that are a little scary because we're taking money off of people. But Stripe provide an API to make that easier, along with an API reference and tutorials and guides. Facebook login API. This one isn't available on every platform, but this provides a way that allows you to integrate the login with Facebook button on your website or web application. And I don't think it'd be right for me to go around this whirlwind tour of APIs without mentioning the Vonage APIs as well. So if you want to send and receive SMS messages or messages on social platforms like Facebook or WhatsApp, integrate video, do two-factor authentication, there are APIs available that allow you to do that. APIs provide functionality that other developers or companies have built and made available to you. So you can use them in your application very much like Lego bricks. Instead of having to build a full login system or take card payments yourself or build video infrastructure from scratch, you can pass that work off to a company who makes that work available via an API, and then you can build what makes your application special on top of it. So a lot of applications you use will be a combination of a bunch of third-party APIs that you're not necessarily or even aware are there, but the developers building it have taken advantage of them. And then they only build the bits on top that make their application work. So let's talk a little bit about how API requests work. And that's what they're called, API requests, when we are using an API. So our application makes a request to an API, which is generally a URL. And it may contain some other settings that we'll talk about in just a minute. So in this case, we hit a friends list page in our social app, for example, and we'll go off and make an API request to get our friends list. So we make this API request, and this kind of API layer does a few things. Firstly, does this request type even exist? Do we contain all of the information we need? For example, if we're creating a new post, do we have text that we're posting? And does this user even have permission to see this data or to post this status or so on? So once those checks have taken place, the operation takes place. So that might be retrieving data from a database in this example, or sending a Facebook message, or checking data from a weather sensor. And once that work is completed, the API will form and send a response, which is often structured in a format such as JSON or XML, and send it back to your application in response. Once again, I'm going to use the restaurant example because it's quite a nice one. I will go ahead and request my food, my dish. I provide the requisite information. Do I want those fries or do I want that salad? Then that request is taken away to the kitchen. Stuff happens back there. You don't really need to care too much. What you care about, though, is that you get a response back to your table and it is delicious. And also, I haven't eaten breakfast yet, so I'm pretty excited for that. And once you get your response back, your application will do something with it. In this case, it will be taking that data and displaying it inside of the page. APIs provide a contract of sorts between the company or developer providing the API and the developer. If you request data in the correct way, using the correct types of request, you're providing the correct data, then you should receive a predictable response. So that is a quick understanding of what APIs are. Let's talk about the ingredients that go into an API request. Now, there are two that are always present in an API request. And there are two that aren't always there, but the API reference or documentation will kind of tell you what you need for any given API. The first thing we need is an HTTP method. And an HTTP method describes the type of request that we are making. Now, in order to explain what I mean by type of request, we're going to take a quick detour to talk about a concept in web applications, or really any application, called CRUD. And CRUD stands for create, read, update, and delete. Now, honestly, almost every interaction you have with a web application will be one of these four. So to use the social network example, we can create a new post. We can read either a list of posts or an individual post. We can edit or update our post. Or if we don't want it visible anymore, we can go ahead and delete it. And this concept of CRUD is not just present in a social network. You can think about it in the context of user accounts, creating an account, viewing a profile, updating details, or deleting an account. Orders at an online store, show me a list of all my orders, or create a new one, or edit it, or cancel it. In Slack, we create messages, we read other people's messages, we can edit them, and we can delete them. So almost every interaction you have with an application will likely be one of these four: create, read, update, and delete, or CRUD. And in the context of HTTP methods, they have slightly different names, but they mean the same thing. So we create entities with a post request. We get data, we read data with a get request. We can update data with a put request, or we can delete them with a delete request. So the first thing we need in our pot of ingredients to make an API request is an HTTP method, such as get or post, which will likely be the two you use most often. The next thing we need is an endpoint, which is basically a URL for the request. So let's take a little look here at the Marvel Developer API. This is the documentation for it. We see they all have a method here, get requests, and they each have a URL as well. They're the endpoints. And dependent on which endpoint you access, you will get different data. So you can get data about characters, about specific comic book issues and series, about the creators of the comic books, and so on. So we will always have an endpoint and an HTTP method. So let's go back to our social media example here. We might have an endpoint for getting a complete list of users. You might think of this as a friends list. Then we have an endpoint for just a single user, viewing someone's profile, for example. There might be an endpoint for all the posts, maybe your feed or your timeline or whatever it might be called, and a single post, and so on. So we'll have these different endpoints in order to access different slices of data in our database. So we will always have an HTTP method such as get or post or put or delete. And there are more. That wasn't a complete list, but they're the most common four. The dog's excited about HTTP methods, aren't you, buddy? And also an endpoint, which is a URL. So let's go ahead and try out one of our interactive segments of this. I'm going to give you some time to work on this. We'll go through it step by step and you can follow along. But there's also a completed example. So don't worry if you're not feeling up for it or you don't have time to complete it. I would love you to go to this URL in a new tab, lws.io/apis-1. Now, what this will do is take a template code base that I've created on a web platform called Glitch, and it will automatically, when you go to that URL, create a copy of it so you can edit it. Glitch is basically an online code editor. So if you go to lws/apis1, and thank you very much, Suze, for posting that in the chat. I will give you just a moment to go there, and seeing as Suze has posted it, I can bring it off the screen. And I'm going to go ahead and do the same, lws.io/apis-1. And while that's loading, I'm going to open up a new tab and show you. No, I'm not going to open up a new tab, actually. I think I've put it in the README here. Give that a refresh, because I'm one of those people where if it doesn't load in a period of time, I will hit refresh, because of course that will make it load quicker. Okay. So in this example, we're going to use data from the You Got This API, which I'll open in a new tab and show you in a moment. And I'll show you it now. This API allows you to get data about talks, about, oh, look, there's a little bit of a styling error there. I can fix that later. About individual talks, all the tags that can be put against talks, all of the events, and so on. So let's talk a little bit about how we read this. And actually, my little CSS error will cause an issue here. So I'm going to highlight the page, and I'm going to read you this text that is still white. So there are a bunch of endpoints here, URLs, and you'll notice that they don't have an HTTP method. Generally, if you don't see one, you should assume it's a GET request. But I probably should put HTTP methods on this page. Now, there's a few things that are important here. Firstly, are these URLs /talks.json, or the one we'll be using today, /talks-flat.json. Obviously, /talks-flat.json isn't a full URL. We can't make a request to just that. Oh, yes. In fact, Delia makes a very good point. I basically just implemented dark mode, and these white bits of text got caught in the crossfire. If you click this accessibility button in the top right, it will skip you down to this dark theme button. Give that a little tap, and now the white text is no longer an issue. Thank you very much for knowing my website better than me. Now, this isn't a full URL, right? We can't just make a request to this. So what you'll be looking for is what is known as a base URL. And here it is. It's https:// And the idea is that you will prepend any of these parts of the URL, or you'll prepend this to this. So the full URL will be yougotthis.io /talks-flat.json. So we'll make that GET request, and what we'll get back in response is data that looks like this. So we see that we're expecting an array, and inside of that array, we're expecting objects, one object per talk, and we expect these properties: talk title, talk abstract, speaker one name, speaker one bio, URL, video slug tags, and so on. So we make the request to yougotthis.io /talks-flat.json without forgetting the HTTPS at the beginning. If we make that GET request, we should get this in response. So our goal is to make this API request inside of our glitch project here and display all of the talks on a page. So what I want you to do is click on talks-flat.json. And this is the data that will be returned. But what you can do is just copy this URL. And this is the full URL. We'll need that later, so keep that copied. Now let's go back to glitch. And we're going to do our work inside of index.html. Now, don't forget, if you are falling behind, or you're not really feeling up for it, or you want to come back for reference later, there is a completed.html that you can use. But we'll be doing our work in index. So let me make that font bigger, and let's take a little look here. So we've got this kind of boilerplated HTML page. It has an H1, Introduction to APIs, an H2, Getting Data from an API, and an empty UL, or a bulleted list. Then we've included this JavaScript library called Axios, which makes it easier to make API requests consistently in the browser. Then we have this function that I've written, which will take an individual talk and it will just add it to that UL. We don't need to mess around with this function. But what we want to do above this is make an API request. And I've given you this little commented snippet here, and this is how we use Axios. I don't want you to copy and paste this. I would love you to type along with what I'm writing if you're able to. Axios dot, and then we provide the method. We don't write the word method. We write the actual HTTP method that we're going to use. And as mentioned, this is a GET request. So we go axios.get, lowercase. Brackets, quotes, and in here, we put the endpoint or the URL. So hopefully you'll have that copied. If not, you can go and grab it again here, or Suze has popped it in the chat, and we can go and paste that in. So that will go off and make an API request. It will take a period of time. We're not quite sure how long it will take. So we will wait for a response. So this is where this second part of the snippet comes in. Dot then, brackets, response, arrow, so equals, greater than, and squiggly brackets and enter. And now the data from this API call, this API request, will be available in this response variable. So let's just go console.log response. And this is a fully working API request. It will go and make a GET request to this URL. And when the data comes back, it will be available in response. So let's take a look at how this works. If we click show and we click in a new window and we open up our developer tools, go to console. This is what is in the response variable. So let's take a little look inside of it. So we have some information here, this thing called headers. We have this status, which is 200. We'll talk about that in a bit. And what we also have is data. And this is our array with 47 items. Now, Rodrigo asked a question in chat. What would be the difference between Axios and a fetch? Good question. You can use fetch absolutely fine. And in many modern browsers, fetch is fine. Axios has greater backwards compatibility. And when you use fetch, there's this middle step where you need to take the readable stream and turn it into a JSON object. And I didn't want to do that today in this workshop, so we're going to use Axios. Axios also works. Axios can also be installed for Node.js, and the syntax is the same. So, so our data, our actual data from the API is in response.data. So if we go back here, response.data, and we now see in our console is just the array. This isn't the whole task, though. We want to display these items in the page. We've kind of done that first step. If I go back to my slides for a moment, we've done this step. We've got the data to our page. Now we want to do something with it. We want to display it on the page. So let's go ahead and do that. I wasn't anticipating going back, so there we are. So we can use this function, and this function takes a single item, not a list. So we're going to do a for loop. There are lots of ways to do for loops in JavaScript. I'm going to use what is known as a for of loop. So we'll go for, oh, wasn't quite what I wanted. For let item of response.data. An item is now each individual talk object. You might choose to call this talk. That might semantically make more sense. That is the individual talk. So that is just this item, for example, just 0. And then the next time it runs, it will just be 1 and so on. And we can write add talk to page, and we'll pass in the talk. So this code will run for every item that comes back from the API. Let's show this again. Let's figure out why that didn't work. Item.talk is undefined. Item.talk is undefined. That is my bad. Item.talk.title does not exist on Talk's flat. It's called talk underscore title. So that's my bad. Apologies for that. Talk underscore title. And there we are. There's all the data being displayed on the page. The completed example does not have that typo. So there we are. So just to recap, my sample said talk dot title, and it should be talk underscore title. But we've just made a GET request to an API. Then the data's come back and we've popped it in the page. So well done. If you've never used an API before, we've just used one together for the very first time. So just to kind of recap the structure of that, we go Axios dot type of method. So get, post, put, delete. We put in the endpoint and then we wait for a response. So a question from Alberto here. Pardon, what is the difference between using .then and async await? I'm not going to spend too long on this for those who are less experienced with async await in JavaScript. You can use both. Async await is a different syntax for waiting for a response, for doing what are known as asynchronous calls. Now, one interesting thing about async await, if we take a look here, is you can't do async await on the top level of a script. It needs to be inside of an asynchronous function. For example, if I wrote async here, or async here, I could then use await inside of this function. But what is known as top level await doesn't exist in the browser at the moment, I think. And if it does, its support is brand new and spotty. So, you can't do await here. That won't work. So we'll use .then. But it does the same thing. It's syntactically just, it looks syntactically different. I'm a fan of async await, but in this context, it didn't make sense. Okie dokie. So this is how we get data from an API. So just to recap, we used an HTTP method and we used an endpoint. And we used some of our live debugging skills to fix my typo. Congrats. Now, these next two ingredients aren't required in every API call, but may well. And API documentation will give you an indication of whether this is required. The next thing is known as a body. And a body is basically a set of data that you send with the request. A good example of things that would go in a body are your actual content of your message that you send. Maybe it's a file if you're going to upload a file. User information like usernames and hashed passwords. A phone number to create a call towards. Back to our social media example. It could be the actual text that we're posting. Remember, if you want to create or update something, then you need to provide some data. And we'll do that using a body. You'll generally send data in a structured format, such as JSON or XML. And post requests often will ask you to send a body with them. So let's jump straight into trying another practical example. Fingers crossed, everyone, because this is another example that I built. So maybe there'll be a typo. What I want you to do is go to your browser and go to api.lws.io. And, we'll find out if this works together. So this is a very minimal API that I built just for this workshop. And this allows you to get a list of people from a database. So we'll do a GET request to /people. And the data that we get back will be an array of objects with a name, a location, a random ID, and a created timestamp. There's also an endpoint, which is a post request to /people. Now, this requires you to send along some data. It requires you to send along a name and a location. And they're both just strings, so you can put whatever you want in them. And if you are successful, it will return to you, it will respond with the full record, the name, location, the ID, which is created for you, and the created date, which is created for you as well. So we're going to try and add ourselves using this API. I'm always a bit cautious of doing like live, you submit data into a database. This is my point to remind you that there is a code of conduct for the event. I'm sure this will be fine, but just a kind note there. So let's just take a look at the features of this API. We have a base URL. So it will be https://api.lws.io/v1/people. And we have to pass in some data. So now we're going to learn how to do that. And we're going to do that by going ahead to the next sample code base that may or may not have typos in it. So if we go to lws.io/apis-2, it will do exactly the same thing. It will take this sample code that I've written and copy it for you so you can go ahead and edit this. So let's go ahead and do that together. lws.io/apis-2. And this will look very similar to what we've just done, with only the addition of the body. Reconnecting, connected. Thank you. Okay. Once again, there is a completed example inside of completed.html, but we're going to work inside of index.html. Now, there is a little bit more going on here. So let's just recap what this file is. So we've got our kind of boilerplate HTML page here. We've got our H1 and H2. Then we've got two text inputs, one for name and one for location. Just as a side note, in the reel, you want to add labels just to make sure that this is as accessible as possible. But I've gone for the minimal code for this example. So we have name and location. We've included Axios again. And what we've done is said, get the button, the submit button. And when we click it, run this function. The code I've written for you gets the value in the name box and the value in the location box. And it does that for you and stores it in a variable called name val and a variable called location val. And now we write our code. We'll write it at the bottom. Once again, I've given you the sample code. So let's go ahead and do this. Axios dot, and this time it's not a get request, it's a post request, as shown here, post. Axios.post, brackets, quotes, and in here, we're going to put the endpoint. So let's do that. Let's go to the top of api.lws.io, grab the base URL, and remember that we need to type in /people at the end of it. So api.lws.io/v1/people. But this is where things are different. Now, what we did before was we went straight ahead, and we can write this together. .then, response, arrow, squiggly brackets. So this is what we did before, except post say get. But currently, there's no way for us to send our body along with it. And as you can see here, we put it inside of this method as a second parameter. So after this close quote, but before the close bracket, we're going to go comma, squiggly brackets. I like to hit enter here, but it doesn't really matter. And in here, we're going to write our body. So this is the object. And in here, we're going to put properties and values. So going back to the mock API documentation, we need name and we need location, right? So let's go here. We need name, and there's going to be a value, and the value is in this variable, name val. So that will be whatever's in the text box. Name val. Thank you very much, folks, posting links in the chat. It's very useful. Thank you. And we need a location val. Now, before we continue, very shortly we'll be able to test this. Just as a heads up, this does insert your name and location into a database. And then remember, there is an API call that allows people to get the data. So you might want to give a country or a city, nothing too specific, please, because other people in this workshop might be able to see that. And then we're going to console.log the response.data. So that is our post request. Let's recap before we test it. Axios.method, which is post. HTTPS API.lws.io v1 people. This one is the body, and then we continue on. So we're going to hit show, and we're going to go into a new window. I'm going to open up my console, just make that bigger, and we're going to test this out. Cross our fingers because I broke this API yesterday. Kevin Lewis, London, UK. Hit submit. Yes. And what we receive in response is the name, the location, the ID, and created. And that means that this data was inserted into the database correctly and is now available on the / people endpoint as a GET request. So there we are. Fantastic. Now I'm taking a look at the time and I feel like I'm running a little bit behind. So I'm going to pick up the pace just a tiny bit. There is one more practical example. And when we get to it, it might be more of a demonstration that you watch than one that we play along with, but we'll see. So we have an HTTP method, an endpoint, and a body. Now, the final piece of information that we may need to send along with a request are headers, which include additional information, which often includes authentication details. I don't have a practical for this, but take note that you may see this in API documentation. So the 4 ingredients needed for an API request is always an HTTP method and an endpoint, and may also be a body and headers. Now, just remember, this is an ideal case. This assumes every person who builds an API uses the correct method, uses the correct kind of structure, and that the reality is that's not always the case. Some APIs might need extra steps to work or may use a GET request when in theory they should be using a POST request. Good API reference and documentation should be able to give you concrete steps. So we take these 4 parts and we package them up into an API request, or going back to our previous analogy, we throw them in the pot of cooking. That's right, the pot of cooking. But yeah, we package them up and we send that request to the server. Now, as noted, the server then does some work, whether that's inserting data into a database, reading data from a database, and eventually it'll form a response and send a response back to you. And we just saw that in action. But what also comes with a response is an HTTP status code. And we saw that it was 200 on that first request we did for the You Got This API. And the HTTP status code gives you a general indication of the result. So here are some common ones. 200 means everything's fine. Everything's okay. And in fact, anything in that kind of 200 range, 201, 204, they all mean like things are fine. Things went fine. 400s mean it's your error as a developer. So it could be that you're not authorized, or the infamous 404 that we're probably familiar with means this doesn't exist. You've tried to access a method and an endpoint combination that doesn't exist. And when we think about that second example we did, the api.lws.io, we did see here success will give you an HTTP 200. An error could be 400, which means that the body you gave was invalid or missing. Or an HTTP 500 is a server error. So let's just recap. We're doing fine on time, actually. So let's just recap. APIs describe a set of instructions that developers can use to interact with a platform. Requests always have a method and an endpoint and can also have a body and headers. Responses have a status code and almost always have a body. So that's APIs. Now let's talk about SDKs, which stands for Software Development Kits. So SDKs are a wrapper around an API that makes it easier and nicer to interact with that API in any given programming language. Ultimately, it still makes API requests, but instead of needing to get Axios every time, SDKs will handle the actual API call for you. So let's use a Vonage example here. This is Vonage API documentations for creating a call to a user. Now it's a bit small, but this is the method, it's posts. This is the endpoint. This is a header that you need to pass in. And here is the body that you need to pass in. And we expect a response of 201 with this payload, this data being sent back to us. So it's very much kind of bringing together the concepts that we've learned so far. Now, one of the interesting things about this is that header there, authorization with your JSON web token, JWT. We're not going to talk too much about those, but these are basically access tokens that only work for a very short period of time. So you need to be generating them often. You need to be tracking them to make sure that they've not expired and perhaps regenerating them when required. And SDKs can make it easier to work with that. So at Vonage, we have 6 server SDKs: Ruby, PHP, Python, .NET, Java, and Node.js, which is JavaScript, which we'll be using today, and 3 client SDKs as well. Ultimately, we'll be making exactly the same API calls, but we'll be making them in a nicer way. So we will try this out now. So I want you to go to dashboard.nexmo.com. If you already have an account, that's great. If you don't, you'll need to sign up for one. We don't have a huge amount of time, so I'm not going to wait around. I'll wait around for, a minute or so to let you do this. And then you can catch up on demand if wanted, or look back at the slides. As a note, Vonage used to be called Nexmo, or the part of Vonage I work for used to be called Nexmo, hence dashboard.nexmo.com. You can go to the coupons section. That's under your username coupons. Stick this coupon in, which gives you some credit, which will be enough to get you quite a long way. And it lists the account restrictions as well. So I'll leave that up for just a moment. Thank you, Suze, for popping that in the chat. And in the interest of time, I'm going to crack on. As I said, this might be a segment that you have to watch more than play along with. But I really want to get to the end bit of content because there's some useful tidbits at the end. So once again, we're going to do the same thing. We're going to go to lws.io/APIs-3. And that will copy the sample code base into your account. Now, in the interest of time, actually, I'm almost certainly going to move a little quicker now. So don't worry if you can't play along. There is a completed example in this code base as well. And I've actually already forked this. I've already remixed this, sorry, is what codebar calls it. So let's refresh here. I also just need to relog into the dashboard, I think. I do. So I'm going to do that, and then I'll bring that on screen as well. Excellent. So let me just pull that in there. Brilliant. So there's a couple of things that we need in order to interact with the Vonage APIs. We need our API key, and we need our API secret. Now, just a note here, your API secret is exactly that. It should be kept secret, and if other people see it, you should regenerate it. But you need your API key and secret in order to link your application to the Vonage platform, and it knows that it's you. So if we go over here and you go to .env, there are two values to fill in: your API key and your API secret. So you can copy those from your dashboard here, API key and secret, and pop those in the .env file, which I'm not going to open because it has my keys in there. Now, a few extra things have happened here. I have installed the Vonage Server SDK, and I have initialized it. I've created a version of it that we can use. And it uses our API key and our API secret from our .m file. That's what these represent. Now we're going to go ahead and we are going to send an SMS. So we go to our Vonage dashboard, and the first thing we need to send an SMS is we need a phone number. If you go to numbers, by numbers, you can get a number that supports SMS and add it to your account, and it deducts the cost of it from your account balance. Here's one I made earlier. Where's my UK one? Right here. So it will be this number that we use, this number here that we use in order to send an SMS. To send an SMS, Vonage.message.send SMS with a capital S in the middle there. And we can do this instead of making an Axios request, because we have included and initialized the SDK. And this same SDK can be used for all the APIs. And there are 3 bits of information we're going to need to put in here: our Vonage number, our own number, and the format here is important. So if you're in the UK, 44, if you're in the US, 1, you don't put the 0 in, and then you put in the rest of the number. This is an example of a mobile number format. And then finally, the actual message. So comma, quotes, this is awesome. And this is our fully working example. So this will work whenever we go to our website /send. It will send an SMS. So let's do that. Open in a new window. And this should error because we haven't got anything at the home page. But if we go to /send, it says OK, and you should receive an SMS message. And once again, don't forget, Completed.js has this example here. As an additional note, applications in Glitch are public. So once you've tested this out, remember your phone number is going to be there. I would delete this or just, replace your number with something else. But that's using an SDK, a little bit different, but ultimately it still makes an API call. It just gives us a slightly nicer interface to that API. And the nice thing about the Vonage SDK is it also handles the creation of those temporary keys, and it keeps track of when those keys expire, and it generates new ones for you. And you don't have to handle any of that. You can just go ahead and send a message or make a phone call, and it will do all of that for you. And you can combine this with the previous example with the form in order to fill in a form and hit submit, and then it sends a message. Cool. Let's begin to wrap up with just some additional things that you might want to keep in mind when using API. So these are basically just some extra terms to have in your lexicon. So when you are looking at APIs, you kind of know what they mean. So this is the Orbit API, which is like a community building platform. They have this section, as many APIs do, called rate limiting. Rate limits basically stop you sending way too many requests to the point where you might make it difficult for the API builders to keep their platform online. So in this context, you can, any given computer machine using your credentials can make 120 requests per minute. Now, sometimes you can pay to increase your account's rate limit. So let's talk a little bit about the common features of API pricing. So one common one is tier-based pricing. You perhaps have a free tier and you have a paid tier or several paid tiers, and they give you different things. For example, this is the new Twitter API payment screen. And you can see here, there's a higher rate limit. You get more data back. Or you get more data back rather than a rate limit. So it could be tier-based. So you pay the amount and you get up to a quota, and whether or not you reach that quota, you pay for that tier's usage. We have this kind of pay-as-you-go model, which is what the Vonage APIs use and what the Google Maps platform uses. So here we have directions, for example, $5 per 1,000 requests. And this might be done with pre-applied credit, where it takes it away from your credit, or you basically rack up a bill and at the end of the month, you settle it, you pay it. There's also this note about how we actually authenticate our requests when we're not using an SDK, when we're just using an API. Some platforms, such as Airtable here, have a single API key. Here it is. And you use that API key forever, basically, unless you regenerate it, perhaps because it's become compromised. So you can use this kind of static key to authenticate all of your applications. As mentioned, there are other ways. So this here's Ably. In this application, in this example, sorry, your application uses your account credentials to generate a temporary access token, and then you use that token to access the features of the platform. And those tokens expire. So if they become compromised, they stop working after a short period, or just generally, you have to keep regenerating them with your credentials. And you use that temporary key. We won't go too much into this one because, oh, look at all those arrows. And this might look like a lot, but it's just one more step from what we just spoke about. You make a request. You pop up a box to a user that has them give you permission. You often see this with things like login with Google or login with Facebook. What that process actually does is provides a code that is temporary that your application can then use to access the resources. So that was a whirlwind tour of APIs. We covered what APIs are as a concept, what goes into an API request, that being HTTP methods, an endpoint, and potentially a body and headers. SDKs or software development kits, along with the quick example of how they can be used to interact with APIs. We also spoke a little bit about rate limiting, pricing structures, and authenticated requests. Now, I have 5 extra minutes here, and that is the end of my talk. So by all means, I'm happy to stick around until the next talk begins. And I believe the next talk is actually about using APIs in React. So that's very exciting. But if you have any questions, this would be a perfect time to share them. Of course, feel under no obligation to ask questions. The next talk, I believe, begins at past in 6 minutes. So if you want to get up, stretch your legs, get some fresh air, that's brilliant. You should go ahead and do that. Thank you very much, Sandra, for the kind words. I hope you found this useful. I know when I started, I'm self-taught. I started with just like front end HTML and CSS, and then I kind of scraped to learn some JavaScript. And this whole world of APIs and SDKs was filled with mystery. So hopefully I can shortcut your learning. Here is a question. Have you used GraphQL? And if so, how do you find it compared to RESTful APIs? I have used GraphQL. I like it. It's the concepts are broadly the same though. You have an API endpoint with a method, you have to pass in a certain body and you get data back. I'm not enough of an expert to have any hot takes or very strong opinions, but I've played around with it a few times and it seems really cool. Any other questions? Awesome. No, just kind words. Thank you very much, folks.